All right, so I want to take a second to talk about significant figures and scientific notation. And this is getting into the part of chemistry where you'll think that the teacher is a real stickler, a real stick in the mud, and making you do this pointless exercise that you'll never use again. And honestly, I think that what it's talking about, or what I'm teaching you how to do, is maybe if you never work in a lab ever again, you might not use this. But what I'm teaching you how to do is to have integrity with your science, how to report the right number of figures, and how to have accuracy and precision in your measurements and whatnot. So this is a good lesson to learn whether or not you go into laboratory science or not. And actually, honestly, I use this every single day. As a physicist in a laser laboratory, I've written reports, and my boss has kicked me back the reports and said, hey, do you have the right number of significant figures? Are you reporting more numbers than you actually should? Because that's, if you are, then it's unethical, or it's inaccurate and that kind of stuff. So actually, I do use this every day. Let me go over the different rules with you. The first one is this significant figures things only apply to actual measurements. So if I have a straight ahead number, then I'm not talking about significant figures, like how many fingers you have. Well, you have, normally people would have 5 fingers on each hand, and that's not really, there's no question in how many there are. So you don't need to say I have 5.00000 finger on my right hand and 5.0000 fingers on my left hand and that kind of stuff. The 0.000, in fact, up to infinity zeros, kind of is implied when you just say I have 5 fingers on my right hand. So that requires no significant figures. Non-zeros are significant. So any number that's not a zero, significant. And then in order to have zeros that are significant, if they're surrounded by, on the right and the left side, by a significant figure, then they are significant as well, the zeros. The decimals will help define which zeros are significant, and I'll show you a little bit about that later. Significant zeros in the ones place are followed by a decimal, and that's kind of in accordance to rule number 4 as well. And then the rule number 6 is the decimal factor in scientific notation contain only significant figures. In fact, to be honest with you, scientific notation is the best way to deal with significant figures. And I'll show you folks what the point of scientific notation is in these examples, and also the usefulness of it. So not only am I going to identify how many significant figures are in each of these numbers, but I'm also going to write them in scientific notation because I think that would be very helpful. All right, so the first one is 9.370 kilograms. Well, first of all, this is a measurement of something. And the rule that I'm looking at is the 937 are significant. So that's 3 of them so far. But this 0, which trails this number on the outside, that is significant as well. So how many sig figs? There are 4 sig figs. And I told you I would teach you a little bit about scientific notation, but this one doesn't require scientific notation because it has a decimal place right after the number itself. So I'm going to skip this one in terms of scientific notation. All right, number B, part B. Now this one I'm writing over here because I think that this one we're going to have good discussions on. All right, so I have 63,000 grams. How many sig figs are there? Well, the 6 and the 3 are significant, so that's 2 of them so far. Now these extra zeros over here, they are not significant. And the reason being is if I wanted to make them significant, I would put a decimal place right there. And then the zeros would be sandwiched in between the 3 and the decimal, and that would make them significant. But there is no such decimal, so they're not significant. Essentially, I kind of think of them as placeholders. I couldn't write the number 63,000 without them, but I still need them just in case they're significant. Um, or I still need them, not because they're significant, but because I needed to, I couldn't write that number 63,000 without them. I have to have something to hold the space while I put in my 63. If I were to write this in scientific notation, I would write 6.3 times 10 to the 4th power grams. Because you can see that if you took the decimal place and you moved it 4 times to the right, you would get this number above. All right, and the reason why I like scientific notation is because immediately, right off the bat, you can tell that 6.3, that there's only 2 significant figures. There's immediately no question into how many significant figures there are in this particular number. There's 2 of them. All right, here's another thing, and this is where I think would be great to, the advantage of scientific notation would be really helpful. You know what? I'll do that when I get to F. So let's talk about this one. C. 705.06 milliliters. Well, this is a measurement, so rule number 1, check. Non-zeros are significant, so we have at least 3 of them. 1, 2, 3. Okay, that's rule number 2. All right, rule number 3 is zeros surrounded by significant figures are significant as well. So let's see, we've got these guys are significant, and then these zeros have all the zeros inside here are also significant. So the number of sig figs that I see is 5. 5 sig figs. Cool? All right. Now, I'm going to have a computer grade some of your mathematically based homework, and honestly, I'm going to put it in so that way you'll get it wrong if you report the wrong number of sig figs. It might be frustrating, and you'll probably have to deal with it a lot of times, but what I mean is you'll have to redo it and then realize, oh, I forgot to do significant figures. But at least it will train you to get the right answer and be very careful with these things. All right, so the next one is 12 cookies. Or a dozen, I suppose you would want to put it. 12 cookies, this is not a measurement. I'm not measuring cookies. Like, I don't have a cookie ruler or anything. So 12 cookies is 12 cookies. It's a counted number. And the significant figures is not applicable. If I'm going to use significant figure rules in multiplication and addition, and that's something I'm going to be teaching you in the next section, I would consider this to have unlimited significant figures. You can consider this 12.0 with a line over it if you really wanted. But I mean, that's kind of pointless because it's a counted number. It's an exact number. All right. Now, part E. 0.0001 second, which is pretty quick, but actually not that quick in terms of when with the I deal with wavelengths of nanoseconds and that kinds of stuff. So 0.0001 second isn't really that big of a or small of a number. All right. This one has 1 sig fig so far because it's a non-zero. And then these zeros over here, all right, this 0 right here, he's out. That's not significant. But I guess the question that you would ask is, are these zeros in the middle, are they significant? And the answer is no, they're not significant. These zeros are preceding the number, and these zeros right here are again more like placeholders, so they're not significant. The only significant number here is the 1, so this only has 1 sig fig. And I forgot to write everything down in scientific notation. Let me go and do that one for this. To write this in scientific notation, you would write the number 1 because it has 1 sig fig. I wouldn't put a decimal because usually you have a decimal and a number after that, so you can just write 1. And then this is times 10 to the negative. All right, what do I need? Do I need 3 or 4? Well, there's 3 places in front of it, But I have to remember, if I write the number 1, I'm writing it kind of with a decimal implied right after it. So in order to make it the same as the number above it, I would need to move the decimal place 4 times. So if you go 1, 2, 3, 4, then you'll have the number that I wrote down, the 0.0000 or 0001. So I would write 1 times 10 to the negative 4 seconds. Cool? And I apologize for number E, or I'm sorry, C. I didn't write it in scientific notation. Let me go do that right now. This would be 7.0506 times 10 squared milliliters. Because if I want to make my scientific notation look like the one above, I need to move that decimal place 2 times to the right. All right, the last one is F. And the number I'm dealing with is 2300.000. And the answer to this one is there's no units. This could be a measurement, but I don't know if it's a measurement because there's no units. I don't know if this is 2300 light years, if this is 2300 hairs, if this is 2300 feet. I don't know if it's 2300 seconds. So I can't tell you if this has significant figures or not because I don't know if it's a measurement. So I would say NA or not applicable, or there's no significant figure digits that apply to a pure number. Now I should write this in scientific notation though, and if this were, like, let's put a seconds on here. Oh look, there's units. Now it is a measurement, so significant figures. And in this case there's 1, 2. Now here's the thing, and this could get a little confusing, is see this 0 out here? That is significant because you don't need that to write the number 2300. You could have just put 2300 without those extra .000. So this one is significant as well. And if this 3 and this 0 is significant, then all of these guys in the middle are significant as well. So there are 1, 2, 3, 4, 5, 6, 7 significant figures in this thing. And if I were to write that in scientific notation, I would want to write 2.300 times 10 to the third power seconds. Now, I told you that there's a very special reason why we would use scientific notation, and it's very helpful to us. Let me kind of do it like this. I'm going to go back to the B problem, and I have 6,300 grams. Now, I told you that there's only 2 sig figs in there, and that's absolutely true. But say that I measured this in grams, and I measured it so that I had a scale that could measure up to 100 grams. You know, and it could delineate between 100 and 200 and 300 grams, but it couldn't, if you put an extra 50 grams on there, it couldn't really tell that because just by the accuracy of my scale. So that actually means that, see this digit right here, the 100 digits, the hundreds place, that is significant. So I have a number now, 63,000, where I want to express that it has 3 sig figs, because the 6 and 3 are significant, and then this extra 0 is significant, but those other 2 zeros, they aren't significant. And there's no way that I could possibly do this, because if I wrote down 63,000, and I knew that this was significant, and you knew that that was significant, but there's no way that anyone else would know unless I told them that that was significant. The only way that you could possibly do this is write it down in scientific notation. You would write 6.30 times 10 to the 4th power and grams. Now you can see, oops, sorry, that's my phone. Okay, all right. Now you can see that it's almost the same as what we had here, 6.3 times 10 to the fourth grams. But over here I added an extra zero, and that's because that extra zero was significant, where I couldn't express that unless I used scientific notation. So you can see how scientific notation can have its great advantages.